Obviously, last Monday we had to prematurely terminate the class. We'll take center of mass from where we left. But even before I proceed, are there fundamental issues related to center of mass that I discussed in the last class bothering you? Anything that you want me to repeat about center of mass ideas? No. So shall I proceed then? Shall I proceed? Now, when I got you triggered into center of mass, I simply spoke of a representation of a particle, equivalent particle or equivalent position, the center of mass position, that could effectively replace the collection of continuous or discrete particles as would be applicable. And I defined that position RCM as M1R1 plus M2R2 plus MnRn by M1 plus M2 plus Mn, right? Why on earth did I at all do that? I mean, never really presented a rationale for having selected that as the center of, that as the effective or the equivalent particle or that position, which could be used effectively for a point position for the sake of applying Newton's second law. I'm going to give you semblance of reason as to why that position was regarded as the equivalent position. And before I do that, let me tell you Newton's generalized second law. Generalized second law. Now, what this generalized second law tells us is, if there is a collection of particles, M1, M2, M3, Mn, that mutually interact, M1, M2, M3, Mn, that mutually interact, that means they exert forces on each other. And if there is a net of all external forces acting on the system, call it F. Net of all external forces acting on the system, call it F. And it is found at this instant, the accelerations of M1, M2, M3, Mn, as let's say A1 is the acceleration vector of M1, A2 is the acceleration vector of M2, An, A3, and so on and so forth. These are the accelerations of various particles. Then the second law, generalized second law, states the following. The net of all external forces F would be M1A1 plus M2A2 plus M3A3 plus MnAn. That's generalized second law. Now, if you conceive of a single particle whose mass is M1 plus M2 plus M3 plus Mn, then that means this collection to be replaced by one single particle of mass M1 plus M2 plus M3 plus Mn, that is the mass of the entire system, then that particle would have an acceleration given by ACM. That's an equivalent particle, right? This is what you would expect out of the equivalent particle. That means the net of all external forces is mass of the equivalent particle into acceleration of the equivalent particle, right? This is what you, so this is legitimate, this is legitimate, right? Which then brings us to the acceleration of the center of mass. The equivalent particle then, as m1a1 plus m2a2 plus mnan whole divided by m1 plus m2 plus mn. So if there is an equivalent particle that is meant to replace this collection, then the acceleration of that equivalent particle, that is the center of mass particle, would be m1a1 plus m2a2 plus mnan by m1 plus m2 plus mn. Now, the position of the equivalent particle must be commensurate with this description. The position vector of the equivalent particle must be commensurate with this description. Very clearly then, if one attempts to position the equivalent particle at RCM given by m1r1 plus m2r2 plus mnrn by m1 plus m2 plus mn, then evidently if you differentiate once, you will get the velocity of the equivalent particle, the center of mass particle. That's m1v1 plus m2v2 plus mnvn divided by m1 plus m2 plus mn. And if you differentiate a second time, you get the acceleration of the equivalent particle ACM. That will be m1a1 plus m2a2 plus mnan by m1 plus m2 plus mn. Which means this description of the position of the center of mass will give me this as the acceleration of the equivalent particle, which matches with this. And therefore, this could be considered appropriate for describing the position of the equivalent particle, because differentiating twice would give me what you would expect as the acceleration of the equivalent particle. So do you realize that that's really the reason why the center of mass is defined thus, so that it could give me this as the acceleration. The objective is to get this. Defining the center of mass this way will give me this as the acceleration. Right? Are you comfortable with this notion now? Now, let me take an illustration. I told you in my last class that if there is a collection of particles, continuous or discrete, and if the only force acting upon them is the mutual force of interaction, and if the net of all external forces is zero, then the velocity of the center of mass must remain constant. Even though the constituent particles could be accelerated, could have different velocities at different times, v1, v2, vn could be different, but vcm will be preserved as long as f is zero on the system, right? As a special case to this, I said, if at some instant for the same thing, if one discovered that VCM was zero, then VCM remains zero at all times. And if VCM remains zero at all times, it means the center of mass stayed put in position. Its position vector remained constant. RCM remained constant. Corollary to this was when I said, all right, the entire force F was not zero, but the component of the force in a certain direction was zero. For example, Fx was zero. There was a force F acting on a collection of particles, F, net of all external forces, as Fxi cap plus Fyj cap plus Fzk cap. And I said, well, capital F is not 0, but let's say Fx was 0. And when Fx was 0, what it meant was that the x component of the acceleration of the center of mass was 0. If the acceleration of the center of mass was Axi cap plus Ayj cap plus Azk cap, then then Fx 0 really meant that Ax must have been 0 because Ax was produced by Fx, right? So this implied that Ax was 0. That means there was no acceleration in the x direction. And in the absence of an acceleration in the x direction, the x component of the velocity of the center of mass must have remained constant, right? So Ax0 would have, suppose the velocity of the center of mass was Vxi cap plus Vyj cap plus Vzk cap, then Ax equal to 0 really implied that Vx was constant. As a special case to this, if this Vx was found to be 0 sometime, then this Vx remained 0 at all times. That means there was no velocity in the x direction at all. And if there was no velocity in the x direction, there couldn't have been displacement in the x direction. And if there was no displacement in the x direction, the x coordinate of the particle must have remained constant. So the implication of this being 0 is really that the x coordinate of the center of mass must have remained constant. X coordinate of the center of mass must have remained constant. X coordinate of the constituent particles could have been varying, could have changed, but m1x1 plus m2x2 plus m3x3 plus mnxn by m1 plus m2 plus m3 plus mn must have remained constant, even though x1, x2, x3, all of them vary. But the numerator's summation mi xi must have maintained its status, right? Now, this is a useful notion and finds good applications. So let me highlight and illustrate an application related to this. Okay, can I wipe this off? You done with this? Suppose, let's say this is the shore of a river, and there is a raft. There is a raft of length L. Raft of length L and mass M. Uniform length. Thank you so much. And effectively, this entire raft being uniform could be replaced by one point particle at its midpoint, right? And when we have to do calculations related to the raft, then this raft I can replace by a point particle at its midpoint wherever required. Let's say then there is a man here of mass small m at one end of the raft, let's say, at one end of the raft. Okay, it does not matter really, but only for the sake of definiteness, says one end of the raft. The raft can float in water, on water. The raft can float on water without friction. Let's assume that the raft is capable of floating on water without experiencing frictional force from water. Without experiencing frictional force from water. So now we have a system, raft plus man. Raft plus man, let's say, is a system, a collection of particles. Raft plus man. Let me call this point of the shore as the origin. Let me call this point of the shore as the origin. And let me designate this as the x-axis. Let me designate this as the x-axis. Now in this state, if I have to compute the center of mass of the man plus raft, position of the center of mass of man plus raft, realize that the coordinates of the man are L0, right? L0, this length is L0. The boat has coordinates L by 2, 0. I mean, you can replace the boat or the raft by a point mass capital M at its midpoint, L by 2, 0, right? So this is like a capital M. Then the x coordinate of the center of mass of the raft plus man, x coordinate of the center of mass of the raft plus man is going to be m into L plus capital M into L by 2 divided by small m plus capital M, m1 x1 plus m2 x2 by m1 plus m2, right? That's going to be the x coordinate of the center of mass of the system, raft plus man, m into L plus capital M into L by 2 divided by small m plus capital M, right? That's the x coordinate of the center of mass of the raft plus man. Now, if the man attempts to move in this direction on the raft, if the man attempts to move in this direction on the raft, right, then of course he does exert a force on the raft. He can walk on the raft because of friction. So he exerts frictional force on the raft. The raft exerts an equal or opposite frictional force on the man, but they cancel off in pairs for the system. Raft plus man, if that's my system, then the two forces, one that the raft exerts on man and the force that the man exerts on the raft in the horizontal direction so that the man could walk on the raft, those forces cancel off in pairs. Right? So in the x direction, do you realize, in the x direction there is no net force acting on the system. In the x direction, the force acting on the system is 0. In the x direction, the force acting on the system is 0. And if in the x direction, the force acting on the system is 0, then the acceleration of the center of mass in the x direction must be 0. Acceleration of the center of mass, see, acceleration of the center of mass is like a axi cap plus ayj cap plus azk cap. In this case, fx equal to 0 would imply ax is 0, acceleration in the x direction of the center of mass is 0. And if that be the case, then the velocity in the x direction of the center of mass must be a constant. This would help this. Yes or no? The x component of the velocity of the center of mass must be a constant. But now, Initially, the man was at rest on the raft. Initially, the man was at rest on the raft, and the raft was also at rest, not on the man. That means the velocity of the man was zero initially, the velocity of the raft was zero initially at some instant. There was an instant when the velocity of the raft and the man, before he started to walk on the raft, was zero. And if the velocity of both the man and the raft was zero, the velocity of the center of mass was zero. The velocity of the center of mass of the raft, because m1 v1 plus m2 v2 by m1 plus m2, if v1 and v2 are both zero, then the velocity of the center of mass ought to have been zero. No? Which means Vx was zero initially. Vx, x component of the velocity of the center of mass was zero initially, yes or no? So if Vx was zero initially, it remained zero always because Vx was constant. If at some instant Vx was zero, x component of the velocity of the center of mass, then it maintained that kinematic status all along. Vx was zero always, right? That means if Vx was zero always, there was no displacement in the x direction of the center of mass of the system. And if there was no displacement in the x direction of the center of mass of the system, it implied that the x coordinate of the center of mass must have remained constant. This clearly meant that the xcm of the man plus raft must have remained constant. That means initially, if you computed the center of mass from the initial position of the man and the initial position of the raft, then even though the man moves, the x coordinate of the center of mass does not move. The x coordinate, I mean, if there is an observer here, and he is reported at some instant, let's say the center of mass of the man plus raft 4 meters away from this end, then the center of mass of the system will remain 4 meters away from this observer in this direction, right? And then realize that for this to remain preserved, for x coordinate of the center of mass to remain preserved, realize that if the man attempts to walk this way, that means this increases, this decreases, right? This does not remain L. This becomes less than L, let's say. Right? This point, this becomes less than L. And if this becomes less than L, then this has to become greater than L by 2 so that this number remains the same. This number remains the same. Do you realize what I'm saying? If the x coordinate of the man decreases, if this number becomes less than L, then this number has to become greater than L by 2 so that this sum remains constant, right? That means one thing for sure, if the man wants to move in this direction, then the raft would have to move in this direction so that the center of mass, x coordinate of the center of mass of the raft plus man remains preserved, right? So any attempt by the man to walk in this direction will result in movement of the raft in the opposite direction to maintain constancy of xcm. No confusion on this, right? Now, let's do some real calculations on this. Let's say the man moves d units on the raft. That means with respect to the raft, on the raft, he walks d units rightwards. D units rightwards. Let's say the man walks d units rightwards. Okay. And the raft moves d1 units leftwards. Let's say the raft moves d1 units leftwards. The raft moves d1 units leftwards. Why would that happen? So as to preserve x coordinate of the CM, x coordinate of the cm, right away? Now, so then in the new state, when the man has walked d units upon the raft with respect to the raft, and the raft has retreated d1 units leftwards, the final x coordinate of the man, the x coordinate of the man would have to be measured from the same point O. From the same point O, see, it was originally L. It decreased by d units, L minus d, but it increased by d1 units because then the raft also moved, right? The man moved upon the raft d units. The man moved d units upon the raft, but the raft retreated d1 units in the opposite direction. So then suppose the raft did not move at all. Then the man would arrive at this position and the coordinates of the man would be L minus d. But now the raft moves in this direction. That means the man also retreats d1 units to the left. So the final coordinate, x coordinate of the man would be L minus d plus d1, right? L minus d plus d1 would be the final x coordinate of the man. I don't have a problem if I have to repeat this. If there is any soul perturbed by this thought. No? Huh? So the final x coordinate of the man, small m, is like L minus d. If the raft did not move, but the raft had to respond, so it responded d1 units in the opposite direction, leading to the final x coordinate of the raft being of the man being L minus d plus d1, right? N plus capital N. The raft has moved d1 units rightwards. Initially, the raft was having its x coordinate L by 2, but now if it has moved d1 units leftwards, its final x coordinate would be L by 2 plus d1, right? So final x coordinate of the raft would be L by 2 plus d1, right? So then this divided by small m plus capital M is going to be the final x coordinate of the center of mass of the raft and man when the man has moved d units with respect to the raft on the raft towards the shore, right? But then subject to preservation of the x coordinate of the center of mass, this must be the same as this, right? X coordinate of the center of mass of the man plus raft couldn't have changed. So then this numerator must have been equal to this numerator because the denominators are the same, and equating the numerators means m into L plus capital M into L by 2 equals m into L minus d plus d1 plus capital M into L by 2 plus d1. Yes or no? Now this ml is going to get cancelled. This capital M into L by 2, this capital M into L by 2 gets cancelled, right? And then this gives us an opportunity to compute d1. I mean, the man would tell you that he's walked 2 meters upon the raft with respect to the raft. You would have to compute how much the raft responds because the raft will not tell you, right? So you'll have to do a calculation on the raft. The man can tell you he's moved x units on the raft, but for the raft, you'll have to calculate. So you would want to know d1. D would be given by the man, d1 you will have to compute, right? So then d1 then turns out to be m into d divided by capital M plus small m. Yes or no? Did you understand the computations involved and why these calculations were made? All of you understand everything that done here? Huh? But doing this was junk. Doing all this was absolute nonsense. I'm not going to do this. What I'm going to now present to you is a different look to the situation, how I would want you to handle the situation. This seemed like very elaborate, very cumbersome, and writing two expressions and then getting very unwieldy. Listen to me carefully, although this will always work, but if you can understand my train of thought in the next 10 minutes, then what I'm going to tell you in the next 10 or 15 minutes is something that you must do instead of doing this. All right? All right then. Same situation, everything else remaining the same. The man has walked d units towards the shore upon the raft with respect to the raft. Okay. I'm going to recalculate the stuff, hopefully with greater simplicity. All right. Imagine the raft to be a thinking person, capricious imagination, but imagine that, well, uh, it could behave like a human being, it could think like a human being and would be very loyal to nature. It will not do anything that will go against laws of nature, go against Newton's dictation. Right. But then, if it's a human being, if it behaves like a human being, it could make mistakes. But if it makes mistakes, it's also, after having realized that there was something that went wrong, it's ready to remedy those mistakes. Imagine the raft to be having such a disposition. Okay. Now, when the man, imagine that when this guy started to walk upon the raft in this direction, the raft was in deep slumber, sleeping. The raft was sleeping. This guy was satanic and wanted to do things against nature, wanted to disrupt the center of mass of the system. He thought that the raft is sleeping. It's not going to respond to my walk. I will disturb the center of mass of the raft plus man. And will cause worries to Newton wherever he is. So then, the Satan then walks d units. The Satan then walks d units on the raft. The Satan then walks d units on the raft, and since the raft was sleeping, it could not respond to that walk. It stayed put. It stayed put. When it did this, the numerator of xcm, m1, x1 plus m2, x2, etc., was damaged by a certain amount. I'm going to again cause all damages in this direction positive, all damages in this direction negative. All damage in this direction positive, all damage in this direction negative. Oh, you can choose the other way around. It's not going to make a difference. So, anyways, it caused a mathematical damage to the numerator of the x coordinate of the center of mass. By what amount? If the raft did not respond, then the damage caused was m into d. to the numerator. Yes or no? The numerator is mi xi. So the xi of this changed by an amount d. So the damage caused to the numerator was m into d. That was the change in the numerator. That was the change in the numerator caused, right? Instead of being xi, it was d different from xi. What is the x coordinate of the center of mass of the system? m1x1 plus m2x2 by m1 plus m2. When I say damage, means change in this number. So let's say since the raft was in slumber, this did not change, but this changed, x1 changed by an amount d. That means this numerator changed by what amount? Mass into d. So that was the damage caused to the numerator, in effect causing damage to the x coordinate of the center of mass, right? You know what I'm saying? So the damage caused to the numerator by the movement of man on the raft was small m into d. Alright. Now the man arrives here, very, very joyous. Rather, the Satan arrives here very joyous, very happy. So, gets intoxicated at this point because he's thrown nature out of gear. He's disturbed the center of mass for no reason. The system. So drinks like a barrel of liquor and goes off to bed. Right? Right here, the man dozes off, imagining that he's done damage, he's harmed. And then that's when the raft wakes up. They have to do something, right? That's when the raft wakes up. And when the raft wakes up, the raft knows that, well, there has been damage caused in this direction to the numerator. And this bloody guy is in slumber. Alright. So what the raft does is, says, I'm going to cause damage in this direction so that the net damage caused to the numerator is 0. So the raft moves even units in this direction. And if the raft moves even units in this direction, the man also, because he's sleeping, the man also moves along with the raft even units in this direction. So now the damage in the opposite direction caused, damage in this direction caused, would come with a minus sign. This is the damage caused by the man, positive, and the negative damage caused by the raft. To counter this is like man plus raft now moving even units leftwards. Man plus raft moving even units leftwards. That's the opposite damage caused. That's the negative damage caused. This is the positive damage caused by the man. Negative damage caused by the raft. Now the man is helpless. वो सो चुका, इतना पी के सो चुका, उसको पता ही नहीं है कि restoration चल रहा है कहीं पर. Right? Does not know that there is restoration going on. And then this d1 would be such that the algebraic sum of the damages would be 0. If the algebraic sum of the damages is 0, the x coordinate of the center of mass is preserved. And Newton showers immense blessings on the raft because this is 0. This is 0. And that's when the x coordinate of the center of mass will stay put, because the algebraic sum of the damages caused is 0. That means d1 realizes m into d by small m plus capital M. Realize that? Although the two processes go hand in glove, the man walks, at the same time the raft floats, and there is simultaneous restoration. But for the sake of imagining things, you can do this and the calculations would be as simple as this. You're going to save yourself a lot of trouble. Got me? Now, wonder why I had to really create these stories for you. Tell you, for just one guy sitting there, it might seem like, almost the same, but imagine the following. I'll refine the situation a little bit. I'll make this a little more involved. Same situation, I'll just make it a little more involved. Can I assume that what I have delivered so far has been absorbed and assimilated by you? Right? Understand? Okay. So now the raft, hmm, man somewhere here, mass M1, wants to come to this position, D1 units to the right? Dog. Hey, come on. I mean, when I can imagine this man to be a point mass, I can imagine the dog to be a point mass. So don't get very cynical and critical about that. So then, the doggy, mass M2, wants to come to this position because there is a bone. भूख लगा है साले को, खाना पड़ेगा, यहाँ पे दिख रहा है. इसको नेचर से क्या मतलब है? D2 in this direction, right? और थोड़ा रैप को बड़ा बना देते हैं, रुको. This is Mr. X and this is Miss Y. Why not? Mr. X obviously wants to go and meet her. मिस वाई भाव खाती है, वो बोलती है मैं यहीं रहूंगी, तुमको आना है आओ. हाँ? We'll talk about that though. एक्चुअली ये दोनों की कॉमन थी, पर ये साला बीच में कुत्ता आ गया ना, प्रॉब्लम आ गया. इसको डर लगा साला, ये बोन की जगह इसको नहीं खा जाए. एंड मिस्टर एक्स बोलता है यार क्या जाना है, कोई कौन सा 5-7-10 माइल जाना है थोड़ा सा राफ्ट में. D3 units to the right. Mr. X mass M3, Miss Y mass M4. Now this guy does his job. यहाँ पे barrels of whiskey गपा गप पीने के लिए, ये साला हड्डी खाने यहाँ आ जाते हैं, ये मिस वाई के पास चला जाता है जो भी करने. एंड राफ्ट बोल रहा है जिसको जो कुकर्म करना है करने दो, उसके बाद मैं एक्ट करूंगा. Let me just quietly witness the damage that all these folks caused to the numerator. I'll act at the end of everything. क्योंकि ये यहाँ जाएगा, उसके बाद he has to fall out to sea. ये खाएगा, इसका पेट भर जाएगा, ये जाएगा, नशे में धुत गया काम से, सब सो जाएंगे, उसके बाद राफ्ट मूव करेगा. right? That's what's going to happen. So now the raft perceives, or like I said, in this direction positive damage, in this direction negative damage. So this guy causes damage M1D1, Kutta, negative damage minus M2D2, and then Mr. X plus M3D3. Right? This is the algebraic sum of damage caused to the x coordinate of the center of mass by the man, the woman, and the dog. Yeah, I mean, so what if she's not moving? She's responsible for the damage. That's why I said damage caused by the woman. And then the raft was mass capital M. बोलता है ठीक है. This is the damage. I'm going to now cause negative damage. So after all of them have dozed off, M1 plus M2 plus M3 plus M4. M4 भी तो move करेगा when raft move. So what? Right? And let's say small d to the left. The raft moves small d to the left plus capital M plus capital M mass of the raft. Right? This is the restoration. This is the algebraic sum of damage. This is the net algebraic damage. And it must be 0. It must be 0. And if this is 0, then you can compute d, the distance moved by the raft, if all of this happened. How will I? No, this d could have been positive as well as negative. You're right. So now, suppose this was not the shore, it was in the middle of the lake, right? It could have moved, d could have been positive, d could have been positive if it's like this, or negative if it was like this, right? If there was no support here, if there was no shore, it would move in this, it could have moved in this direction. It could have moved. I'm not saying that d could have been positive as well as negative. But if there is a shore, right? And if d turns out to be negative, that means the raft wants to move, the shore will prevent it. Suppose there is no, then it will move in this direction. Does not matter. No. Because these are all changes. These are changes in the numerator. Whether you measured these positions from here or you measured it from Jumri Talaiya, the change is still going to be the same. Right? These are all changes. D1 is the change. D2 is the change. These are damages caused to the numerator. Yeah, I mean, reason I assign a minus sign is that if D then turns out to be positive, then it's indeed like this. If D turns out to be negative, it's like this. That's the reason. But it does not matter. And now imagine if I had handled this situation with the initial set of computations, then for the next 1.5 months, we would be doing the x coordinate of the center of mass of raft plus man. This is what we would be doing. So do you realize that now looking at the whole scenario from a damage and restoration standpoint makes life so much simpler. Are you all there with me on this? Huh? Also a similar situation. Let's say there is an inclined plane. Angle theta, frictionless, smooth, resting on another frictionless surface. Resting on a frictionless surface. Mass of the inclined plane, capital M, and the base of length, capital L. Base of length, capital L. Mass small m, initially on top, at rest, slides down the inclined plane, slides down the inclined. I want to figure out the distance traversed by the inclined plane by the time this mass m comes to the bottom of the plane. I want to compute the distance traveled by the inclined plane so that by the time this mass m reaches the bottom, this would have traveled a certain distance, the inclined plane travels a certain distance. Now, one thing for small m plus capital M, let me call this direction, the horizontal direction, as the x direction. As the x direction, right? Say, this is the origin, O. In the x direction, is there any net external force acting on the inclined plane plus block? In this direction, is there any, see, is there any Fx? Fx is 0 on the system, right? There is an external force in the form of gravity. There is an external force in the form of gravity, but that's vertical. In the horizontal direction on the inclined plane plus the block system, there is no net external force acting. They exert forces on each other, but they are normal forces internal. They cancel off for small m plus capital M blended together. Okay. Now, evidently, when the mass m comes down, this point, it's moving in this direction. So the x coordinate of small m is increasing, right? So in the expression m1 x1 plus m2 x2 by m1 plus m2, this x is increasing. So the x of this must decrease. That can happen if capital M moves rightward so that it can preserve the x coordinate of the center of mass, right? Yes or no? Again, we will superimpose the two situations. We would imagine the inclined plane to be sleeping initially and the raft and the block causing a certain damage. When let's say the block does not respond, the raft comes to the bottom position. The raft comes to the bottom position. When it comes to the bottom position, by what amount has it got displaced in the x direction? Capital L, right? It has got displaced by an amount, capital L in the x direction, right, Jay? When this comes down here, what is its displacement in the x direction? Capital. So what is the damage that it has caused to the numerator of the center of mass? Right, m into a small m into L is the damage that it has caused. So once this has caused that much of damage, small m, then small m plus capital M move in this direction by an amount x, so that the restoration is minus small m plus capital M into x, and this is the net algebraic damage. This must be 0 so that the x coordinate of the center of mass for the raft for the block plus the inclined plane remains preserved, right? So x is m into L divided by m plus n. Got me? Well, in the vertical direction, I can't preserve the center of mass because there is gravitational forces acting. So it's accelerated in the vertical direction. So the y coordinate of the center of mass is not preserved. Evidently, you can see that the center of mass has fallen down of the system. I mean, when it comes here, this is still here. The y of the center of mass of this remains the same. The y of this has decreased. So the y of the center of mass of the system has obviously decreased. That happens because there is unbalanced gravity. Yeah. All right, listen to me. Capital M, capital Mg, reaction R, right? small m mg, right? Normal reaction that block exerts on m and m exerts on the block, equal and opposite, right? Do you still believe that mg is balanced? Mg is unbalanced, right? So there is an unbalanced gravitational force acting on the system downwards, right? So there is acceleration of the system, acceleration of the center of mass in the downward vertical direction. So you don't have y coordinate of the center of mass remaining preserved. This small mg is unbalanced. Very simple stuff here. Let's anyways go past some calculations, understand what's happening here. You don't have a copy of the sheet? You don't? No? So problem 1, two particles of mass 1 kg and 2 kg, m1 is 1 kg, m2 is 2 kgs, are initially 10 meters apart. At time t equal to 0, they start moving towards each other with under mutual attraction force. Under mutual attraction force with uniform speeds of 2 meters per second and 1 meter per second. Right? We want to find the displacement of the center of mass in time t equal to 1 second. Okay. One thing for sure, in this situation, let's say this was the x direction. On the system, there was no net external force. They moved under mutual attraction. They exerted forces on each other, but there was no external force acting on m1 and m2 as a unit, right? So Fx was 0, no force external in the x direction on the system at large. So acceleration Ax is 0, means Vx is constant. Velocity in the x direction of the center of mass, must be a constant if there is no acceleration in the x direction. Now, so at this instant, whatever I compute as the velocity of the center of mass will remain the velocity of the center of mass at all instants, right? So velocity of the center of mass at this instant of time would be 1 into 2 plus 2 into minus 2 into 1, right? m1 v1, and in this direction, see, v1 is opposite, minus 1, so I'm taking this as positive, this as negative. So m1 v1, and then m2 into v2 is minus 1, divided by m1 plus m2, that is 3, that is 0. In this case, it turns out to be 0. Velocity of the center of mass turns out to be 0. So is there any shift in there is no velocity of the center of mass in the x direction, so there is no shift in the center of mass, right? And where would be the center of mass here? The center of mass would be at what distance? I did this calculation in the last class. If there are two masses, let's say this is the origin, this is 10 comma 0, the center of mass is at x, then x would be m1 into 0 plus m2 into 10 divided by m1 plus m2. That would be x, right? I take this as the origin, then this becomes 10, 0. If x is the position of the center of mass as seen by this is x, then the x coordinate of the center of mass would be m1 into origin 0 plus m2 into 10 divided by m1 plus m2. This would give me the x coordinate and it will stay in this position. Both the masses are moving, but their x coordinate will remain the same because the velocity of the center of mass in the x direction is 0 and constant, right? So this will be the x coordinate of the center of mass, which will remain the same at all instants of time. Now, Where would they meet therefore? Where would they meet? At the center of mass. Because if they didn't meet at the center of mass, if they met here, then this would become their center of mass. But the center of mass couldn't have changed positions, isn't it? They must meet, therefore, in this case, at the center of mass. Because the center of mass is not nudging from its position. They have to meet at the center of mass. Realize that? In this situation, they have to meet at the center of mass. If they didn't meet, if they came here m1 plus m2, both at the same position, then their center of mass will come to this position if it's not this. Which would mean that the center of mass is moved. But the center of mass is not moving because the velocity of the center of mass is 0. Right? So they meet in this case at the center of mass. Can I wipe this off? So we have for problem 2, a 1 kg block, 1.5 meters per second. This is 37 degrees. 1.2 kg block, 0.4 meters per second. One meter per second, 37 degrees, 1.5 kg, 0.5 kg, 3 meters per second, 1 kg, 2 meters per second. We want to be able to compute the velocity of the center of mass of the system. Alright, what you may want to do is you may want to design your x and y coordinates as follows. You may want to say that this is your y direction, this is the x direction. You can do that, right? If I did that, then for this mass, what would be the velocity vector? The velocity vector would be minus 1.5 cos 37 degrees I cap, and then in this direction minus 1.5 sin 37 degrees j cap. Tell me. Right? That's the velocity vector for this mass v1. The velocity vector for this mass v2 is 0.4 j cap. 0.4 j cap is the velocity vector for this mass. The velocity vector for this mass v3 is minus 1.0 cos 37 degrees I cap plus 1.0 sin 37 degrees j cap. Right? The velocity vector for this mass v4, 2 cos 37 degrees I cap minus 2 sin 37 degrees j cap. These are the velocity vectors. Right? So then the velocity of the center of mass would be m1 v, v5 would be 3 I cap. 3 I cap, right? So VCM would be m1 v1 plus m2 v2 etc. divided by m1 plus m2 plus etc. This would be the velocity of the center of mass. This is how you would do this calculation, right? Two blocks of mass 10 and 20 kgs are placed on the x-axis. The first mass is moved on the axis by 2 centimeters. By what distance should the second mass be moved so as to keep the position of the center of mass remain unchanged, right? That means, let's say this has moved 2 centimeters. This has moved 2 centimeters, right? Let's say this has moved 2 centimeters. The displacement, that is delta x of this, is 2 centimeters. This, let's say, gets displaced to the right by amount delta x2, right? Now, the change in the numerator is 10 into 2 plus 20 into delta x2, this is the change in the numerator, m1 into change in x of this, m2 into change in x of this, that must be 0, yes or no? Which gives me delta x2 as minus 1. I've chosen delta x2 in this direction, it turns out to be minus 1, that means this shifts by 1 centimeter leftwards. If the shift in this direction is minus 1, what it means is there is 1 centimeter shift in this direction. Yeah. So if this is moved to the right by 2 centimeters, this moves leftwards by 1 centimeter so that the center of mass stays in position. I hope all of you understand what I did here. M1 into delta x, M2 into delta x, that must be 0. So that delta x of the center of mass is 0. So that delta x of the center of mass is 0. नहीं क्या राहुल कुछ confusion है ना थोड़ा नहीं ना and it turned out to be minus. It is in the opposite direction 1 centimeter. Yeah, you could have, then you would have got delta. Then if you had taken delta x in this direction, let's say if I had taken delta x2 in this direction, then I would have said minus 20 into delta x, right? So that was 3a. Similarly, 3b. Two bodies of masses 10 kgs and 30 kgs are placed along a vertical line. (10 kg), M2 is 30 kgs. They're placed along a vertical line. The first block is raised to a height of 1 centimeter, 7 centimeters, sorry. Raised to a height of 7 centimeters. And this is raised by a certain amount delta x. This is raised upwards, let's say, by a certain amount delta x, such that the center of mass gets raised by an amount 1 centimeter, such that the center of mass gets raised by an amount 1 centimeter. I need to find delta x. I repeat, the problem is there is a mass here and there is a mass here. The change in x of this, change in y of this mass is 7. The change in y of this mass is delta x, such that the shift in the center of mass is 1 centimeter, right? So vertical shift in the center of mass would be m1 into vertical shift of m1 plus m2 into vertical shift of m2 divided by m1 plus m2. Yes or no? The vertical shift in the center of mass would be m1 into vertical shift of m1 plus m2 into vertical shift of m2 divided by m1 plus m2, right? So, okay, I mean in this case it's, you can call it m2 is some delta y2. Delta y2 you have to compute. Delta y is given to be 1 centimeter already. So 1 centimeter. So M1 is 10 kgs into 7 plus M2 into delta y2. M2 is 30 kgs. Delta y2 divided by 40. So 40 minus 70 minus 30, delta y2 turns out to be minus 1 centimeter. That means this has to be moved downwards by 1 centimeter. That means this has to be moved downwards by 1 centimeter. Clear? Problem 4 then. Problem 4. A projectile is fired from a gun at an angle of 45 degrees with the horizontal and with a speed of 20 meters per second relative to the ground. 20 meters per second at an angle 45 degrees. This is what it would have undertaken if nothing happened. At the highest point, and of course this distance you can compute, this range r is u squared sine 2 theta by g. So u squared 20 squared by 10, right? So you know the range 40 meters, you know the range 40 meters, u squared sine 2 theta by g. At the highest point in its flight, the projectile explodes into two fragments. The projectile explodes into two fragments of equal mass. There is a fragment m, there is a fragment m. 2m is the total mass of the projectile. It fragments into two pieces, m and m. One fragment comes to rest and falls vertically. So one of the fragments is going to fall this way and it lands up here. So one fragment lands up here, right? The other fragment, m, continues to move in a manner. Now, the other fragment, m, goes this way. And it lands somewhere here. And it lands somewhere here. The other fragment lands somewhere here, let's say. Of the two fragments, one goes this way, one goes this way, one lands up here, the other lands up there. We need to find out. So we know where this fragment lands. This fragment lands at 20 meters. This is half of the range, 20 meters. We need to find out where exactly this fragment is going to land. Where exactly this fragment is going to land, right? That's what we need to find out. Now, conceptually, what it means is when they explode, then on the system of small m and small m, there are internal forces which they exert on each other, right? There is an internal explosion, they exert forces on each other, but that's internal for small m and small m. The only external force acting on the system is gravity. Only external force acting on the system is gravity of small m plus small m. Which means the external force acting on the system is only vertical. The external force acting on the system is only vertical. The horizontal force acting on the system is Fx is 0. Now, if Fx is 0, it means even when they fragment, the center of mass will have the same displacement in the x direction. I'll repeat. I claim that while this goes down there, this goes down here, the center of mass must still fall here. Why? 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 Because as far as the center of mass is concerned, of the two masses, the center of mass is not being acted upon by horizontal forces. It's only being acted upon by a vertical force. So the displacement of the center of mass in the x direction would be what it was when the total projectile was intact. When the total projectile was intact. So the center of mass would land up here of the two masses. The center of mass would be here. While this lands up here, this lands up here. The center of mass of the system must still be here. Why? In the horizontal direction, the velocity of the center of mass remains constant. So just before fragmenting, I'll repeat, please understand this very carefully. Just before the projectile got fragmented into two pieces, the center of mass had a velocity u cos theta like this, right? U cos 45 degrees had a velocity u cos 45 degrees, yes or no? The projectile had a velocity u cos 40 just before the explosion, the combined mass 2m had a horizontal velocity u cos 45 degrees, right? That means the center of mass of the projectile was u cos 45 degrees horizontally. Are you there with me? Huh? Just before the explosion, the velocity of the center of mass was u cos 45 degrees. After explosion, why would the velocity of the center of mass not be u cos 45 degrees? It would not have been u cos 45 degrees if there was a horizontal force acting, which would have changed the horizontal velocity of the center of mass. There was no horizontal force acting on the system, unbalanced, for the velocity of the center of mass in the horizontal direction to change. You know what I'm saying. If you're lost, I can repeat this, but if you've understood, I'll proceed. I'll repeat this. See, just before explosion, all right, the velocity of the projectile was u cos 45 degrees. It remained the same, right? U cos 45 degrees was the velocity of the projectile. And if this was the velocity of the projectile, this was the velocity of the center of mass also, because one unit, so it will be synonymous with its center of mass, right? That is just before explosion. Okay, now the explosion took place. The explosion took place, and in the horizontal direction, there was no net force acting on the system. Was there any net force acting on the system in the horizontal direction? That means, was there any horizontal acceleration on the system? There was no horizontal acceleration on the system. That means, if there was no horizontal acceleration on the system, then at this instant, just after explosion, why would the horizontal velocity after explosion be any different from the horizontal velocity before explosion of the center of mass? Just before explosion, the horizontal velocity of the center of mass was u cos 45 degrees. After explosion, it continued to be u cos 45 degrees. Why? Because there was no acceleration of the center of mass in the horizontal direction. There was acceleration in the vertical direction equal to g, but in the horizontal direction there was, right? So the center of mass just after explosion, the center of mass still had a horizontal velocity u cos 45 degrees, and had a vertical acceleration g, Now at this point, if it had a u cos 45 degrees and had g, it will move along this path, it will move. That means the center of, even though one mass fell this way, the other mass fell this way, the center of mass was unaffected in trajectory. The trajectory of the center of mass was still this, because it was guided by a u cos 45 degrees and g. G caused vertical displacement, u cos 45 degrees remained unaltered during this trajectory. Are you all there with me on this? Right? So one mass falling down vertically, the center of mass going along the original proposed trajectory, The center of mass experienced no change, no kinematic change at all, right? And the other fragment had to go this way, so that between these two, the center of mass is right here. And if these two are equal masses, if this lands here, this center of mass would be exactly halfway, right? Exactly halfway. That means realize that this was 40 meters, this was 20 meters, so this also had to be 20 meters, because these are two equal masses. Their center of mass will lie exactly halfway between them. Yes or no? If there are two masses that are equal, so the center of mass will lie exactly halfway between these two. So if this is 20, this had to be 20. So the other mass lands at 40 plus 20, that is 60 meters from the point of projection. Lands at 60 meters from the point of projection, Raghav. Do you understand that one mass falls this way and the center of mass follows this trajectory? So the other mass must land somewhere here, so that the center of mass of this M and this M is between them. And if these are identical masses, then their center of mass would be exactly halfway between the two masses. Now this range is 40 meters. This is 20, so this has to be 20. So this whole thing is 60 meters. So the other fragment lands 60 meters from the point of projection, given all of this. Yeah. Hmm? Problem 5. You've read the problem. Gravity free space, no force in the vertical direction. There is no displacement of the center of mass in the vertical direction. There is no displacement of the center of mass in the vertical direction. Right? Isn't it? Hmm? Now, a boy of mass 60 kg standing over a platform of mass 40 kg, placed over a smooth horizontal surface, he throws a stone of mass 1 kg with a velocity 10 meters per second at an angle 45 degrees with respect to the ground. Find the displacement of the platform on the horizontal surface when the stone lands on the ground. Right? 5 you've understood, right? Problem 6. A boy of mass 60 kgs a boy of mass m equal to 60 kgs is standing over a platform of mass 40 kgs over a smooth horizontal surface. This whole thing is on a smooth horizontal surface. He throws a mass 1 kg with a velocity 10 meters per second. At an angle of 45 degrees with the horizontal. Mass m prime is 1 kg. With respect to the ground, find the displacement of the platform with the boy on the horizontal surface when the stone lands on the ground. So now, this up to this point is the platform. This whole thing is the platform. Whole thing is the platform. And The projectile lands somewhere here at P. Find the displacement of the platform with the boy on the horizontal surface. That means the boy plus platform would have to move in this direction, so that in the x direction, let's say this is the x direction, the center of mass of the system is preserved. See, reason being, there is an increase in mx in this direction because the stone lands somewhere there. There is an increase in mx in this direction. So then there must have been mass m plus capital M moving in this direction so as to counter that increase in mx, right? To counter that increase. Now, what's the increase in mx in this direction? 1 kg stone into the range of the projectile. That's the increase in mx in the numerator. That's the increase in mx in the numerator. And that causes small m plus capital M to move x units to the left to counter that increase. You realize that small m plus capital M moves x units to the left so that this change in this direction is countered by a change in the opposite direction, so that the numerator of the x coordinate of the center of mass remains same. What? Sorry? No, तो स्टोन तो यार छोड़ दिया, बिछड़ गया पेरेंट्स से. अब वो उसको ये थोड़ी प्लेटफॉर्म मूव करेगा तो वो स्टोन को के साथ कांटेक्ट में ही नहीं. तो स्टोन अपना काम कर रहा है, सेंटर ऑफ मास को चेंज करने का कोशिश कर रहा है. बट इन द एक्स डायरेक्शन फॉर द स्टोन प्लस, सी प्लेटफॉर्म खाली यहां तक है, बाकी तो हॉरिजॉन्टल सरफेस है. Right? So now the stone is not moving with the platform. The stone is only within the jurisdiction of gravity once released. Right? This is fine, right? Mr. Verma and Mrs. Mathur, we have dealt with this stuff already, right? To discuss a mechanics problem, they come to the middle of the boat. Of course not. So I'm not doing problem 7 for you anyways. Alright, I'm not doing problem 7 for you. I mean, we've discussed variations to 7, so I can skip this. What not? What not? 7 है essentially वही 8 है. Balloon. Mass capital M. ये सबसे मुश्किल पार्ट है साला बंदर को बनाना. हाँ? Go and eat it, यार. The balloon, the light rope, and the monkey shown in figure are in rest in air. If the monkey reaches the top of the rope, by what distance does the balloon descend? By what distance does the balloon descend? Now, see, in this case, just one point of contention. The balloon and the monkey system. Balloon and the monkey system, of course, the force that the monkey exerts on the rope is the force that the rope exerts on the monkey, and that's internal to the system and not going to bother you. you might be tempted to believe that there is gravity acting on the system downwards. But don't allow that temptation to prevail. Because yes, there is gravity, but it's countered by upthrust, so that there is no net force acting on the system. Balloon is floating in air, it experiences an upward force, upthrust, which is countered by. We will assume that there is no net external force anyway. In the vertical direction, there is no net external force, right? And now, imagine that the balloon does not respond and the monkey climbs to this point. So the damage that he causes to the numerator is m into L, and then the balloon responds. Opposite damage, m plus small m into y, moves down y units, so that this algebraic sum is, right?